I'm really happy to be here. Not just to be here because I can speak to you and I can meet you all. Mainly to be here back on a live meetup. Yeah, it's been a while since this was possible, and I think it's really cool that we see live meetups popping up again and again, and it's getting more and more. And I would really like to have a special thank you to the organizers of Vienna.JS for making this possible. It's really cool. So a hand of applause, I think, is more than deserved. Also for me, it's the first time to do such unplugged things. I usually present with MacBook and slides. So please bear with me if not everything is working out perfectly. When Miro asked me if I want to do this, if I want to talk about something at Vienna.js at the Auto meetup, he was mainly thinking about the talk I did a few times already ago about micro frontends, which I also talked at HNConf in January. But I said it's quite hard to talk about such a technical topic without having kind of code snippets, without having slides. So that's why we decided to phrase the talk like it is called now, the state of single-page applications in 2020. The title is really genius because you can talk actually about everything, yeah, behind this title. And that's what we mainly will do today. We will not compare frameworks on a metric level or on a GitHub style level. We will go into concepts to make you understand what are the differences and why you should maybe care. Yeah? So first things first, my name is David Leitner. Usually you see a slide with a face on it. It's not so important because you can see me anyway. I work for a company which is called Square Solutions. We are a rather small company in Vienna. And if you need anything, just feel free to reach out for me via email or via Twitter. My Twitter handle is StuffLight. Most of you, I guess know. It was a funny joke back then because of the P and so on, but it stayed like this. Yeah. I have here this one slide. I will build my whole presentation around this one slide, and you see here two axes. And I want to first understand from the audience here how familiar are you with single-page applications. So first of all, I mean, that's an easy question. Who could build a production-ready application with a single-page application framework, with just one? Doesn't matter which one, doesn't matter if it's React, Angular, Vue.js. Who could do this? Okay, so I would say 80%. Who could do it with two different single-page application frameworks? Production-ready application. It's about, I would say, 50%. Who could do it with three or more? Okay, it's 10 to 50%, I would say. Okay. So those who can do it with just one single-page application framework, so those who can just do it with Angular, React, or whatever you have, it doesn't really matter to me. Do you think that this is the best framework of choice for your given problem? So those who had the hand up when they said they are able to build it with one framework? Who is able to build it with one framework? So that the first part, just with one. Okay, and you, do you think it's the best choice? Cool. It's not an exercise. You cannot be wrong. I just want to understand it. Okay. And those who could build it with two different frameworks, who of those thinks that one of those two is much better than the other one? Huh?
Depends on the problem.
Yeah, that's of course true. But do you think one of them is usually better in 90% of the cases?
90 is too much.
Okay.
Maybe 60%.
Maybe 60%. Okay. Now, what I actually want, because I do this exercise usually at clients a lot, and I ask exactly those questions, and it turns out, I just need a few stickies. It turns out that the curve is usually like this, right? So this is the number of frameworks people know, and if you do it like this, right? So somebody knows one framework, somebody knows two frameworks, somebody knows three frameworks, somebody knows four frameworks, and so on and so forth, right? And if you ask those people who know one framework, and if you ask them, do you think that's the best choice out there? I would say 80% of them say yes, right? If those people know at least 2 frameworks and you ask them again, do you think one of those is much fundamentally better than the other one? I would say 50% just say, yeah, one of them is much better, right? And if people know more than 2, 3, or 4 frameworks, usually the number is very low where they can say, hey, one of them is much better. And then they usually start with the famous sentence, it depends, yeah? And when we talk about frameworks, this is not a framework-specific problem. I think this is generally a thing in software engineering, right? There's this age-old saying that if you meet somebody who is strongly believing that his programming language is the best one for whatever problem and his programming language is better than any other programming language, then the chance is usually very high that he only knows this one programming language. Yeah? And this is the same for frameworks. And this is what I wanted to bring as an example to set a little bit the stage. I'm not here to tell you which framework is better. I wouldn't even know it, honestly. I'm here to compare them based on concepts, and a few concepts which should be the past of the frameworks, which should be the current status quo, and which should be the future. Make sense? Cool. Then I need to remove them again. And I would like to start with a topic when it comes to single-page applications, which is reactivity. Who knows the term reactivity? Who knows what is meant by it in the context of single-page applications? Okay. When we talk about reactivity, we need to, I think, understand mainly 3 things. The first one is streams. The second one is reactive programming. And the third one is reactive architectures. I will go quickly into detail about all of them. So first things first, who knows what is a stream? Who could explain to his parents on the phone what a stream is? Okay. I have I think a good example when it comes to streams. Reactivity was actually phrased by physics, right? So Albert Einstein worked on reactivity, and it's all about time and space, actually. Yeah. And when you think about time and space in programming, if you think at the lowest level of time and the lowest level of space, you have something like a value, right? With a getter and a setter. You can write a value, and you can get a value, right? If you go further on the right-hand side into space, you have something like a list or array or whatever you call it, or a collection, right? With a generator and with an iterator usually, right? Okay? If you now go up in time, but stay in singular space, you have something like a promise usually, right? Something which has one value, but you will maybe get it in the future, right? And what do you think is here now? Exactly, that's what a stream is, yeah. And I think with this comparison, it should be quite straightforward to understand what streams are, right?
Your dad understands this.
I never tried it, but fair point, yeah. Yeah. So this is about streams, okay? This is the first building block to understand reactivity. The second one is reactive programming, right? So again, what is reactive programming? Very simplified reactive programming. I will collect this afterwards. Reactive programming can be shown in a very simple example, right? So let's assume you have a variable a, like this, right? I know nobody uses variables these days, but I try to make it a little bit language agnostic. So variable a, which has the value 1. Okay. I never programmed that fast, honestly. Variable b, which has the value 2. Surprise. Okay. What has this to do with reactivity, right? Well, it starts with variable c, and variable c is suddenly a little bit different, because variable c is a plus, oh, I should have not separated this so much, a plus b, right? Okay? So what is c? Should be simple. This is not a tricky question. It's really that simple. It's 3, right? C is 3. But what happens now if we would go here and would, for example, change this to 4? Nothing would happen, right? And that's a problem. I mean, this could be the problem. And there are programming languages or there are frameworks, for example, Svelte, which allow us exactly to build this reactivity, right? Which allow us to, for example, add here a $sign in front of it and make this reactive, which would mean if you would change this variable b to 4, this variable c would be ultimately 5. Yeah? And that's reactive programming. And if you think about it now, then this is a stream and this is a stream. This is a stream of values, and those values can change over time, right? And this is a stream transformation. For the Angular developers, this would be a pipe map a plus b, right? And every time a changes and b changes, c changes, right? And this is reactive programming at its heart, right? It's just staying in sync and staying reactive, right? The term is actually quite self-explaining. Okay? So we nearly got it. The last building block for reactivity is reactive architectures. I think it's very important, especially in this context, to understand that reactivity is not something which you usually just do on a programming level, but reactivity can bring a lot of more benefits. Yeah? So let me just collect my stickies. So if you think about modern architectures these days, or they don't even have to be modern, let's just think of architectures, then you usually have something like this. You have microservice, you have a second microservice, you have a third microservice, you have a lot of microservices. The more the better. Just joking. And those microservices usually have databases, right? So this microservice has its database on its own. This microservice has a database on its own. And this microservice has a database on its own. That's the fundamental idea of database of microservices. That every service is autonomous and has its own database and persistence, right? So the question is now, how does the usual architecture look like beyond those microservices? You usually have some kind of gateway. Okay, and then you have some kind of application, right? So you have, for example, React applications. Who uses React? I guess there are people who use React, right? It's interesting to also get to know the audience again. Who uses Angular? Okay. Who uses Vue? You use everything. I feel like. Who uses Stencil? Stencil, yeah. Okay. Who uses Ember? No Ember users anymore. Sad, Ember is a great framework, but I will put it on the side. Who uses Elm? Elm? No Elmas. Who uses Svelte? Yes, very good. And who uses HyperApp? Still HyperApp users here? Huh? You used it or you still use it?
We want to get away from it.
Okay. Okay, fair enough. Good. So yeah, that's usually the blueprint architecture, right? You have some kind of client application, whatever it is. I just used this now to get a little bit of a picture what people are using here. You have some kind of gateway and you have these microservices, right? And let's assume the HyperApp or whatever you have, the Angular application wants to fetch the latest profile from a person. Then it goes to the gateway, says, hey, give me the profile. The gateway goes to some microservice, fetches the profile data. The microservice usually needs to go to other microservices to fulfill the whole profile, right? So it's a very synchronous process. So HTTP itself is of course synchronous. So you make a response, you make here a response, this makes here a response, and ultimately you get back a response, right? And it doesn't really matter if you build your Angular application with HTTP client, which returns you an observable, right? Then you have here this kind of artificial reactivity, but in the end, your whole architecture is not reactive. Your whole architecture is very synchronous, right? And this comes with a lot of downsides. First of all, the downside of resilience, right? If one of those microservices falls apart, so it starts to burn, this is what it should show. Well, let's just remove it, right? One of those microservices is lost, right? Then you have this problem of resilience usually, yeah? So you cannot get some data which you need for the profile. If you have a really good team, they will build the client in a way that it still keeps up running and that it just doesn't show those fields which we got from these microservices. But honestly, you really need a mature team. I rarely see microservice architectures which are built in such a resilient way, unfortunately. But that's what I observe at least at clients. Yeah? And that's one of the issues, of course, because we need to go here all the time, and those Angular applications need to fetch those things synchronously, right? And the second downside is if you have a second channel, let's assume you have a mobile channel. So this is a mobile phone for those who don't know it anymore. It's easier to paint than a smartphone. Then this phone has the problem, if you, for example, change the profile data, right? If you go here and say, hey, change the first name or whatever you do, right? Then they don't get notified about this. They need to fetch it again, or they need to press a 5, or you do some polling, or whatever you do, right? And it doesn't really make too much sense. So from a UX perspective, and also from a resilience perspective, this architecture could be improved, yeah? And this is where reactive architectures come into play. Because reactive architectures don't believe in this kind of databases here for each microservice. They believe in microservice, of course, everybody believes in microservices. So we still have those 3 microservices. And on top of this, we have a new concept, which is usually called a stream, yeah, as we learned what a stream is. So you could also call it a data pipe, or it could just be called Kafka or Pulsar or RabbitMQ, whatever it is, right? But the idea is that those microservices are talking with the stream. They not talk directly to each other, they publish events. So for example, if a new customer is created, then you publish an event to this kind of event queue. And once this event is published, this guy here can subscribe to this event queue and can say, hey, if a new customer is created, then let's make a risk check, how risky this customer is, right? And then you get a risk profile event, and somebody who is interested in your risk profile event could listen to this, right? So we have this kind of asynchronous communication and decoupling on the backend side, which we don't focus too much on now because it's not part of this session. But what we also then usually have here, we don't have this classical gateway anymore. We have something which we usually call a hydration. You can also call it simple front-end cache, or that there are multiple terms for it. I like the term hydration most. So it's hydrating the current state of the system for the UI. And the interesting thing of the hydration is here that, for example, if there's a new risk profile, the hydration will get notified and will fetch the data and will store it there, right? And this hydration then provides the data to the front end. And you could replace this hydration by GraphQL, for example, because GraphQL is mainly used as hydration. So you can love GraphQL for multiple things. You can love it for its schema. You can love it for the querying mechanism it supports. But you can also love it for being a perfect hydration. And if you think about this now, if the UI has this hydration, where the data is stored in a way how the UI needs it, yeah, then you can fully decouple those systems. Because every time you get here an event which is interesting for this kind of UI application, the data is stored in a hydration. This is a DynamoDB, this is a Hasura, GraphQL instance, whatever it is, right? Usually it's GraphQL these days. And the interesting thing is you get a lot of resilience here, because those services could be down for 25 minutes and you could still read all the relevant data which you need for the customer. And if somebody makes some kind of mutation here, right, then you just store it here until the services are available again. And this has this huge advantage, and that's why you usually use GraphQL for this, because GraphQL has this direct subscription support, right? You can really stream data from the backend to the front end, and you really move from a classical pull architecture to a fully push architecture. And that's actually amazing, yeah? So these are reactive architectures, right? So GraphQL always works best with mutations and subscriptions, yeah? Keep this in mind if you ever work with it. And from this perspective, we got this kind of resilience because we can actually close this and this application would still work. We have this kind of huge, massive scalability where we say, if we would have a mobile client, this mobile client would also have its own hydration and we would store data in a way how we would need it here, right? And from this perspective, we have this decoupling of the different channels, and we also have this kind of scalability and resilience advantages. Yeah?
But if the microservice is down, it would not work.
Sure, it would work because the data is stored here.
But the microservice would probably use some kind of logic because otherwise it's unnecessary.
Sure. I mean, that's what I meant. You can always read from it, yeah. But of course, mutations would be held back until the system is available again.
So it wouldn't really work. It would be a weird interface.
Yeah, but if you look at it,
The app doesn't update. It's still showing me the old data.
yeah, you can update the hydration, for example, right? You usually do this in an event-driven approach where you would collect the updates, yeah, and then you would publish them back to the core systems. But you could, of course, update the hydration. You could also update the hydration and say, hey, it's not persisted yet, but this is your current state, yeah? Okay? So in 80% of the use cases, it's more important that people can read than they can always write, right? If you have the choice, it's better that you at least can read. But in this architecture, you always can read, yeah? But it's a very valid question. Of course, it doesn't make a system fully resilient. If something is dying, then something is dying, right? You cannot do like nothing happened. But this kind of streaming comes with a lot of advantages. And one of them is, of course, resilience and scalability. But another one is what I discussed before. If this mobile client now makes a mutation, right? If he changes the customer name, then this goes to this kind of event queue where he say, hey, I want to update the customer name. Then the customer microservice updates the customer name, writes back, hey, the customer name was updated. And both hydrations, which are maybe listening to this event because it's interesting to them, right, can update their data in their hydration, yeah? And with GraphQL, you directly stream this out because people are usually subscribing, and every time the customer changes, you get this directly reflected here. It would be cool if I could show you this directly in code, yeah. Unfortunately, that's working. But this is what it is about reactive architecture. And I don't want to go too much into detail because it would not make sense in this limited time. But I just want to make this point to make you understand that reactive programming is not just using observables, and reactive programming is not just, you know, putting dollar signs in front of your Svelte code. It's much more. And I think it's a very, very future movement because I see more and more people going in these reactive architectures. And I would expect more and more people going there if they would know these concepts. So I think lots of people are still building synchronous microservice or synchronous architectures because they do not know better. Yeah. So I think this is a huge trend which is coming up in the next few years. And the advantage is that we have started it more or less from a front-end perspective, because I would just continue here exactly like this, because if you now think about the reactiveness, right, which I tried to explain you with these three examples, then we can again make this comparison when it comes to reactiveness in single-page applications, right? And I would, for example, select here Angular, because I guess very many of you are familiar with Angular, and the second big player is, of course, React. And I like to use those, not because I think they're the best ones, but they are super easy to compare. I will just remove this here again. So Angular and React, okay? And if we talk about reactiveness, in those two particular frameworks, just need to, it's a mess. Then we have usually two kind of things, right? We have what is a price, We have component-driven development. That's what we have in all single-page applications, and we have HTML. And in addition, we have again HTML. Well, actually, it's the other way around. We have HTML, and we have no. It's a very own on a lot of things. We have JavaScript. Sorry, yeah. We have JavaScript 2 times, right? And the order here is very important, and I will explain you what this has to do with reactiveness. Yeah. For those who know me already, I guess know this saying, but the fundamental difference between React and Angular is actually the flow of data, or the centricness of the framework. Yeah? That's the main difference of the concept. So in React, you create HTML out of your JavaScript, right? So React is a JavaScript-centric framework where you start with the JavaScript, and out of the JavaScript you render the HTML, right? In Angular, it was always the other way around, right? Even if it's a little bit fluffy now, but the idea was always to start with the HTML and bind to the JavaScript, right? So in React, you create HTML out of JavaScript. In Angular, you bind JavaScript to HTML. That's the fundamental difference between those two frameworks if you think of it on a very abstract level. This has, of course, a lot of impact on all the other design decisions, but this is the main difference, yeah? And sorry. And the coming back to reactivity now is here, that in React, that's why it's called maybe React, yeah, you can create this HTML just directly out of JavaScript, right? And reactivity in React is implemented in a very simple way, because if you think back about this const or this variable ABC example, where I said whenever something on variable B changes, this should also be reflected in variable C, right? And whenever something in this JavaScript or something triggers this JavaScript, this has a direct impact to the HTML, right? And reactive programming in React is done without observables and without RxJS most of the time, because you could directly subscribe this JavaScript to something which is of interest for you, like a GraphQL subscription, and then this would automatically reactively render this HTML. And if you think about React, and if you think about what I showed you here, that you have this kind of subscription to the hydration from your React application, and this mutation to your hydration, and this kind triggers some kind of action, which again gives you some kind of state, and that's actually Redux, right? And that's why it plays so well together with reactive system in itself, because Redux itself is a reactive system, right? On the Angular side, it was a little bit harder always, because you had HTML and you had JavaScript, so you had this HTML-centric view, and that's why we helped ourselves here with observables and things like this, which make the binding kind of reactive, yeah. But of course, the natural reactiveness is given in React and usually not so much in Angular, based on this fundamental core decision back then. But this was a different target group, right? Here was React targeted JavaScript engineers which should have been able to build cool UIs, Angular targeted web engineers which should have been able to detach the HTML with JavaScript. So far, so clear? Okay, I just need to order my notes. So how is it? Yeah. Okay, that's what I actually want to tell you a little bit about reactiveness. I just want to give you those insights that I think reactiveness is not just on a programming level. I think reactiveness is a movement in an architecture space itself, and I think it will have an impact on the way how we program things. But in general, it is those three things, right? It is this kind of being super easy to synchronize between channels. It supports us with resilience, and it supports us with scalability based on these ideas of not being a pull but a push architecture. Okay, the second thing, when I ask people, hey, what are you interested in actually when it comes to single page applications? And I expected the space to be a little bit much bigger, but I will still make it, then they usually talk about virtual DOM. And they wanted to understand what is the virtual DOM and what is actually Angular using and what are other frameworks using if they don't use the virtual DOM. So who knows the virtual DOM? Really, nearly everybody, that's cool. So there's a virtual DOM, and the second thing is somehow the incremental DOM, right? I will start with the virtual DOM. So the virtual DOM usually looks like this, right? It's a UI representation, yeah, the other way around more or less, but it doesn't really matter. It's a UI representation of what you usually have in your application, right? And then you have something like a native DOM. And every time you change something between this kind of on this kind of application, where you, for example, click a button, this would update the DOM usually, yeah. And updating the DOM usually reflects when you click a button, this updates the DOM, and this usually needs to be reflected on the browser DOM, right? And React, for example, uses this kind of virtual DOM, where they say, we store the current representation of the native DOM, and when somebody clicks on a button, we just create a second virtual DOM, right? And we kind of just compare those virtual DOMs, right? And the diff between those virtual DOMs is then really reflected in the native DOM. And this is the advantage that native DOMs, that native DOM manipulation and reading the native DOM and understanding if something has changed is usually quite cost intensive. So that's why they solved it with this representation of the native DOM in a virtual DOM, right? And whenever you change something, or whenever the user changes something, they create a second virtual DOM, do the diffing, and then reflect it on the native DOM. And this was somehow invented by React. And lots of people said, wow, virtual DOM, that's the best thing ever. And it was really cool, and it is still really cool. But it's interesting that more and more people are adopting to some kind of different DOM, yeah? And that's the second topic after reactive programming, which I want to touch a little bit more in detail, is virtual versus incremental DOM. Yeah, who knows the concept of incremental DOMs? Is there somebody who has experience with Vue.js 3? Okay, a little bit. Okay, because there's definitely a rise of incremental DOMs. Yeah. I mean, also React itself is not a pure virtual DOM anymore, but doesn't really matter. But incremental DOMs have a different behavior. Usually you have, as I said before, this kind of components here, right? I just make this as a yeah. Just fell apart. So you have these components, right? They look like this, small squares, nice small squares, yeah. And you have multiple components, right? As you have here in one virtual DOM, you have them totally separated, and you have them autonomous, right? And if you think about an incremental DOM, then Angular, after the Ivy compiler, is a very good example, because what they do is they compile each component to a fully separate autonomous DOM representation, actually functional, which can manipulate the DOM, yeah, and which even knows when and how to update the DOM. And if we come back to the virtual DOM, the main disadvantage which people have with the virtual DOM is this example, this honestly stupid example of having a list of 10,000 items, right? Where you see how long does it take React to reorder those 10,000 items, right? And usually that's a problem with the virtual DOM, because you have, you know, this diffing, and diffing is also not for free, even if you do it on a virtual DOM basis. And you always need to diff the whole DOM for each interaction. That's the performance downside of React, actually. And with Angular and also with Vue.js 3, they changed this approach totally. They said, no, we don't want to have this big virtual DOM, which we compare to each other. We want to have fully autonomous independent components which are compiled down to JavaScript functions, actually. And every time something changes, we tell this JavaScript function, hey, one of your property has changed, do whatever you want to do with it. But we don't do a general DOM diffing. And this comes with two advantages. This, in the case of the very long list, this comes with the advantage that if this is the list component, it could already say, okay, this was just a reordering of the list. I don't need to tell the list item that it should do anything, right? And the second thing is, and this brings me nearly to the end, is that you don't need this kind of rendering engine here, right? Because if you have two virtual DOMs, you need some logic which makes the diffing of those two virtual DOMs, right? And this comes with the downside that you always have this kind of runtime dependency, and that you always have this kind of, at least, yeah, that you always need this runtime dependency. And this kind of incremental DOM brings us the advantage of having compiler-first frameworks or compilers other new frameworks, because you move all your runtime dependencies to the build time. Yeah? And this is the main idea behind Vue.js 3, why they went to incremental DOMs, and this is the main idea also behind Angular, because they can say, we can now start to tree shake the runtime dependencies or the dependencies we need, because if these components for rendering don't need anything of this rendering engine, like, I don't know, some special functionality, we can easily tree shake it here. Here the rendering engine will always stay as fat as it is, right? And you cannot get rid of this. And this brings me already to the last part, which I want to go into detail, which is compilers or the new frameworks. And I think this is a very interesting movement in the world of single-page applications, where we see more and more frameworks. I did put all of them. Svelte, for example, is kind of an example. A better example is even Stencil. What they actually do is they are not a framework anymore like we know it. They are kind of a compiler which just generates some kind of high-performing JavaScript without any runtime dependency. And this is, of course, the advantage that we can decrease the size intensively. And for Stencil, for example, this has even the advantage that it compiles down to web components and to pure web elements, right? So you don't have any third-party dependency. In the best case, you really compile it down to web standards. Yeah. So I know that everybody wants beer, so I will really make it short. I would have two more points, but I will not add them too prominent. I even don't find them right now. The two more points would have been CSS in JavaScript and TypeScript. I already knew that I will not make it to talk about them, so it's not so important, because the advice for both of those topics is similar. Just use them, yeah. we can talk about it later at a beer, yeah, if you're more interested, yeah. I hope that you understood the main ideas which I wanted to give you, yeah. This idea of reactive programming, how an important role it will play in the future of single-page applications and in architecture itself. This movement from virtual DOMs to incremental DOMs back again, yeah, we had this in the backend world also, where we said we need runtime. We need runtimes, because at runtime we can make systems more performant, because we can learn from the system during its runtime, and move now back to ahead of time compilation, and that's actually also what's happening in the single page application space. And this idea of micro frameworks, where you really just have a compiler and not a whole framework anymore. And of course, yeah, just use CSS and JS and TypeScript. Yeah. That's it. That's all. Thanks for taking your time. I hope it was useful. Just a last sentence from my side. A few people from Vienna, including me, are organizing a conference this March. It's called CodeCrafts. So if you're interested in these topics, we will have also speakers like Max Stoiber there, one of the thought leaders in the CSS and JavaScript space, but also many more. We will also have workshops exactly on the topics like reactive architectures and reactive programming. So if you're interested, feel free to visit us there and to join CodeCrafts in March 2021. Yeah. Thanks a lot for having me.